Hello, it's Matthew here, and I'll be taking you through question 7, which is a 50-mark question on functions. So A part 1 wants us to complete the table below, showing the values of h of x for all the values of x, so that's for x between 0 and 6. However, 1, 3 and 6 are already filled in, so we only need to worry about 0, 2, 4 and 5. Now there are two methods to do this. You can either put those values into the function up here, and the corresponding answers you get will be your heart rate at the various times. However, there is an easier way, and I would say a quicker way to do it on your calculator using the table function. If you're not familiar with this function, I recommend taking out your calculator now, and I'm going to do it on screen. As long as you have a Casio calculator, the method should be the same. The layout might be slightly different, but it's the same method. So you're going to click Menu, which is up here at the top, and then you're going to click number 3, and then you'll get f of x is equal to. Now I know in our case here it says h of x is equal to the function, and on the calculator it says f of x, but don't worry about that, it just means the function, and our function here just happens to be called h of x, and on the calculator it's f of x, but the answers will still be the same. So then you type in your function, which is minus 0.38 x cubed, Now I'm going to give you a tip here, and that's to put the x always in brackets, as the exponent, which in our case here is 3, must be read correctly. So you don't want that to read it as minus 0.38 cubed and x cubed. It's just, the cubed is just on the x. So to avoid the calculator misreading what you put in, I would always put the x in brackets. So then I get minus 0.38 x in brackets cubed, and this just makes sure that the calculator will read that right. And then you're going to do plus 2.6 x squared. And once again, the x is in brackets. Minus 0.13x. Plus 158. Now, if you have the newer model, you'll also be prompted to type in another function which is called g of x. You can ignore this as we only have the one function, so just click equals to again. And now you're going to get this thing called the table range. So if you're on the newer version, there'll be these three things will be together on the screen at the same time. If you have the older version, they'll come up separately. So you're going to start at 0 because the first time we want to work out is time at x equal to 0, which is obviously just going to be starting at 0. And then the last value you have to work out is 6. So you're going to end at 6. And to go down to the next row here, you just click equals to, and then type in 6, and then equals to again. And then the step. Sometimes people get confused about the step. The step is just the gap between each one. So for example, if you're starting at 0 and ending at 6, it's going to go up 1 every time. So it's going to start at 0, go to 1, 2, 3, 4, 5, and 6. Okay, so the step is just the gap between each number in your table. So normally we would have the step at 1, sometimes it's 0.5, but the majority of the time it will be 1. So once you've all those in, just click equals to, and now we have our table. So 0 is 158, 1 is 160.09. Now it does give us a few decimal answers, but if you read in the question, it clearly says, give each value of h of x correct to the nearest whole number. And a whole number is a number that hasn't got a decimal in it, so you have to round it up or round it down, and that's what you're going to write into the table. So copying the values into the tables, we have 158 for 0, 1 is 160.09, and that rounds down to 160, however that's already in, so we don't need to worry about that. 2 is 165.1, that rounds down to 165, so we're going to write in 165. 3 is 170.75, and that rounds up to 171, which once again is already in the table. 4 is 175.76, and 5 is 174.85. So both of those are going to round up to 175. And then 6 is already done, but you can make sure that your answer for 6 should match the value for 6 on the calculator in the table. So that's our value for A part 1. And now we're going to have a look at A part 2, which involves drawing a graph. So here we have to draw the graph of h of x on the axes for x between 0 and 6. So I'm going to mark in all the coordinates of the graph, and the coordinates of the graph are just basically the value we worked out before. The x value is the 0, 1, 2, 3, 4, 5, 6, and the value on the y-axis is the 158, 160, and so on. And just to remind you, the x-axis is this horizontal axis here, and the y-axis is the vertical axis here. So h of x can be rewritten as equal to y, as that just means the function is equal to y. It's the same thing, okay? So the y-axis is always the vertical one, and the x-axis is the horizontal one. And your first coordinate will always be the x-coordinate on the horizontal axis. So in our case here, time 0, heart rate 158, which is going to be our first coordinate. So it's 0 on the x-axis, which is going to be along this line here. And we're going to go up to 158, which is right here. And that's going to be our first coordinate. And we're going to continue to do this for 1, 2, 3, 4, 5, and 6 is already done. So for 1, we're going up to 160, which is right there. For 2, we're going to 165. 3 is 171. 4 is 175. And 5 is also 175. So now let's draw in our curve. So it should look something like that. Your curve on your paper should be a bit neater than mine. It's just hard to draw it on this, but it should look very similar to that. Now, part A in total, parts 1 and 2, were worth a combined 15 marks. Now let's have a look at part B. So now I want us to explain what the coordinates of the point A, which is 6196, represent. And this is to do with Joseph's heart rate. So let's go up at the graph and have a look. So this is the coordinate here. And we know that the 6 is the value on the x-axis, and the 169 is the value on the y-axis, and the 6 represents the time in minutes after the start of the session, as that's what the x-axis represents. So we can write in after the session here. And then the y-axis represents the heart rate in beats per minute at that particular time in minutes after the session started. And the y-axis represents the heart rate in beats per minute for the time in minutes after the session started. So after 6 minutes, Joseph's heart rate is 169 beats per minute, and that's essentially what coordinate A represents. So it's 6 on the x-axis, which means it's 6 minutes after the session has started, and it's 169 on the y-axis, which means his heart rate in beats per minute is 169 beats per minute. So therefore, the coordinate A represents that after 6 minutes of the session starting, Joseph's heart rate is 169 beats per minute. So just to recall, the 6 is the time in minutes after session started, and the 169 is the heart rate in beats per minute at that particular time. So now that we know that, we can say that 6 minutes after the start of the session, Joseph's heart rate is 169 beats per minute, and that's exactly what the coordinates of the point A represent. And that's my answer for part B, which is worth 5 marks. Now let's have a look at part C. So with part C, we're asked to continue the graph that we done before, and from point A, we have to continue on, staying the same level for the next 2 minutes, and then decreasing at a steady rate of 10 beats per minute for the next 2 minutes. So I'm going to do the first part first, which is staying the same for the next 2 minutes. So Joseph's heart rate at the point at the coordinate A is 169 beats per minute. So it's asking us to stay the same for the next 2 minutes. So that means between 6 minutes and 8 minutes, Joseph's heart rate is going to stay as 169 beats per minute. So that means I can draw a straight line across from where coordinate A is to where it would meet the 8 on the x-axis, which is going to be along this line here somewhere. And now I'm going to get my ruler and draw a straight horizontal line across from A to where it would hit that yellow line, which is right there. And now I can erase my yellow line. I don't recommend drawing in really strong dark lines on your page. I was just doing it there to help it make it more visible that it's going to be where it hits the 8 on the x-axis, which is that line there that I had in yellow. So now let's go down and see what the second part of the question said. So it decreases at a steady rate of 10 beats per minute for 2 minutes. So that means it's decreasing at 10 beats per minute every minute for 2 minutes. So at minute 8, his heart rate is still going to be 169 beats per minute. Now remember, his heart rate is decreasing by 10 beats per minute every 1 minute for exactly 2 minutes. I know that's a bit wordy, but we're just going to start with the 1 minute part of it first. So after 1 minute, his heart rate will have decreased, will have fallen by 10 beats per minute. So if it's at 169 beats per minute now, after 1 minute that's going to fall by 10, so just minus 10, and 169 minus 10 will give you 159. So after 9 minutes, his heart rate will be 159 beats per minute. And that's going to be somewhere around there. And now we're going to do the same thing for after 10 minutes. Once again, you're going to take away 10 from 159, and 159 minus 10 is equal to 149. So after 10 minutes, the heart rate in beats per minute is going to be 149, which is about there. And now, once again, we can connect where we finished the T line up there, down through both those yellow points, and that will give us the decrease of 10 beats per minute after 2 minutes, or sorry, for 2 minutes, I should say. And then we'll have completed our graph. So that's our final answer for part C, and part C of the question was worth 10 marks. Now let's have a look at part D, and part D tells us the number of calories per minute that Joseph burns after X minutes, and it gives us this function to work it out. H of X is Joseph's heart rate at the time, and that's the same function as from part A of the question up at the top. So now we're asked to work out C of 6. So essentially that means you're just going to put in 6 wherever you have X in the graph. Now this is slightly harder than the ones you're probably used to, because normally you don't have a function inside a function, but that's exactly what you have here. So this H of X inside the C of X function is also a function. So you don't normally get that in these type of questions, so it's slightly trickier. So let me just write it out first of all. So we're trying to find C of 6. So that means wherever you have X, you're going to put in a 6. So then we get 0.1 times by H of 6 minus 7. Now be careful there, it's 0.1 times by H of 6 minus 7, so you could put brackets around the H of 6 if you really wanted to, but just know you're multiplying H of 6 by 0.1. Now, as it happens, we actually have H of 6 from part A of the question. So let's go up and have a look. So H of 6 is going to be where X is equal to 6, and X is equal to 6 here at time 6 minutes. And we've already worked out, or we've already actually been told, we didn't work this out, that the heart rate after 6 minutes is 169 beats per minute. And that's that right there, okay? So you can work that out again if you want by putting in 6 into this. And if you work that out, you should get an answer that rounds to 169 beats per minute. So now that we know that H of 6 is equal to 169, let's put that in for H of 6. And then we get 0.1 times by 169 minus 7. And we can pop this into the calculator. Now you might still have it in the table function from before. So if you do, just click menu again. So clear everything first by clicking AC, then click menu, and then click 1. And then you're back into the normal mode. So you can do 0.1 times by 169 minus 7. And you get 99 over 10. Or by clicking S to D, you get 9.9. And both answers are valid and you'll get full marks for both answers. So he burns 9.9 calories per minute. So that's our answer for part D, which was worth 5 marks. Now let's have a look at part E. So Joseph has a smartwatch that beeps 15 seconds in the session. So it starts at 2:55 p.m. and finishes at 2:23 p.m. as he finishes. So now we have to work out how many times his watch beeped during the session. Now you're including the first and the last beep. You might not think that that's important now, but it actually is at the end, and I'll explain to you why it is. So first of all, we have to work out how many minutes between 2:55 and 3:23. And if you work that out, you should find there's 28 minutes between 2:55 and 3:23. So obviously there's 5 minutes between 2:55 and 3 o'clock, and then 23 minutes between 3 and 23 minutes past 3. So 5 plus 23 is going to be 28. So once you have your 28 minutes, we can do the next step. Now it says that it beeps 15 seconds, every 15 seconds, I should say, every 15 seconds during the session. So if it beeps every 15 seconds during the session, we have to work out how many times per minute it beeps for the session. So obviously there's 60 seconds in a minute, and now we're going to divide 15 into 60 to work out how many times it's going to beep per minute. And you'll find that 60 divided by 15 is 4, and I'd imagine you are probably aware of that already. So if it beeps 4 times every minute and it's on for 28 minutes, we can find it out by multiplying 4 by 28, and 4 by 28 is 112. Now this is where the including the first and last beep comes in, okay? So we have included the first minute, we've included the second minute, so we've included every single minute up until 3:23. However, at 3:23, that's when he switches off the watch, but it's going to beep at 3:23, but it's not going to beep anytime after that. So at 23 minutes past 3, in that minute, it's only going to beep once, not 4 times. So in that last minute, which is going to be essentially the 29th minute, so it's the next minute that we haven't counted, it will still beep once as it includes the last beep, which is at 3:23 p.m. So he has one beep at 3:23 p.m. Does not beep every 15 seconds after that. It is just literally one beep at 3:23. So we're going to add one on, which leaves us with 113 times. So because he's switching the smartwatch off at 3:23, which is at the end of the session, it's only going to beep once during that minute. Every other minute, it'll beep at the start of the minute and then every 15 seconds until the start of the next minute. But at 3:23, it's only getting its first beep and then he's switching it off. So that means it only gets one beep at 3:23 rather than the usual 4 beeps. And don't worry, we didn't include the 3:23 in the 28 minutes up here. This 28 minutes up here included the full minutes from 2:55 to 3:23. However, 3:23 was not a full minute, it was just the start of the minute. So we haven't included that already, don't worry. So that's our answer for part E, which was worth 5 marks. If you forgot the +1 there, you still got 112 marks, but of course we're always aiming for full marks, which is 5 out of 5. So now let's have a look at part F, which is the final part of this question. And now we're asked to solve this equation, which is the first derivative of h of x. And this tells us how long after the start of the session Joseph's heart rate is at a maximum. So we have to give our answer in minutes to 2 decimal places. So there's 2 important things here. The first thing is that it says to solve. And second of all, it says correct to 2 decimal places. So whenever we're asked to solve an equation, that means find a value for x. So if you're not aware of that, I would write that down. Whenever you're asked to solve for a variable or solve an equation, it means find the value for x. Now, it might not always be x. In my case here, it's x, but sometimes it could be y, sometimes it could be t. Normally it's a letter, it's pretty much always a letter, but just be aware of that. So whenever you're asked to solve an equation or for a variable, it means find the value for x. So that means at the end, you should get x is equal to something, and whatever it's equal to will be your answer. Now, the second thing I want to point out is that it says to solve it correct to 2 decimal places. So now you may recognize this equation here, this type of equation, and this is a quadratic trinomial. Now you might have your different terminology for it. Normally we'd call it a quadratic trinomial. Some people just call it a quadratic equation. I'm going to use trinomial, quadratic trinomial, and we have 2 ways to solve a quadratic trinomial. So everyone has their own preferred first method, which for me it's the guide number method, but there's also different methods. Or you can use the minus b formula. Now, whenever it says to solve a quadratic trinomial correct to 2 decimal places or to any amount of decimal places, so if it's 1 decimal place, 3 decimal places, 2, whatever it says, if it ever says it to correct to a certain amount of decimal places, that means use the minus b formula. So that's literally your hint there. Whenever you see that beside a quadratic trinomial, that means use the minus b formula. Okay, so make sure you're aware of that, because in the exam, it won't specifically say use the minus b formula. All it'll say is solve this or give your answer to 2 decimal places or to 3 decimal places, whatever it might be. So we're going to use the minus b formula here to solve this. And the minus b formula is in your formula and tables book on page 20. So now the a, which is the first thing we're going to mark in, is the number before the x squared. So it's the coefficient of the x squared, which is another way of saying the number before the x squared. So in my case here, the a is going to be minus 1.14. Now don't include the x squared, okay? So the a is just the minus 1.14. It's not the x squared. Some people get mixed up and put in the x squared there, but don't put in the x squared, okay? It's just a is equal to minus 1.14. B is the coefficient of x, or in other words, the number before x, which in our case here is 5.2. And finally, c is the number without any x term, which is going to be the minus 0.13. So now let's pop in our a, b, and c into the formula. Now, some people put in the entire thing into their calculator at the same time. First they do it with the plus here, and then they do it with the minus there. However, I recommend doing this in steps, as it'll be easier to spot any mistakes that you might make, and as well the calculator could read it wrong if you put it all in at the same time. So let's try it. We're going to do 5.2 squared. Then we can click minus and then put this all in brackets. So minus 4 by minus 1.14. And close the bracket after every term. And then finally by minus 0.13. And this will give us what's underneath the square root sign. And it's 26.4472. So that means we have minus 5.2 plus minus the square root of 26.4472 all over 2 by minus 1.14. So we have minus 5.2 plus minus the square root of 26.4472 and then 2 by minus 1.14. You can probably work that out without a calculator, but if you do need to use one, do. That should work out to minus 2.28. So now we're going to split this up into the positive and the negative. So when we have a plus sign here and a minus sign here, and now we can pop both of these separately into our calculators. So the first answer, which is the one with the plus, is 0.025138.5. So to 2 decimal places, that would be 0.03. And then for the second one, we can just change the plus to a minus up here. And that gives us 4.536264967. So to 2 decimal places, that will be 4.54. And it was looking for the maximum one. And obviously here, the one that's bigger is the 4.54 minutes. So that one is our answer there. So his heart rate is at a maximum after 4.54 minutes. Now you have to make it clear that your answer is the 4.54 minutes. If you don't make it clear which one is your final answer, you lose 1 mark. Overall, it's worth 10 marks. So making it clear that your answer is 4.54 minutes gets you the full 10 marks. However, if you leave both answers, the 0.03 and the 4.54 there, without making it obvious which one is your final answer, you lose 1 mark, which leaves you with 9 marks. And of course, we always want to get full marks. So therefore, I highly recommend making it obvious that your answer is the 4.54 minutes. So that's my answer for question 7, part F, the final part of the question and the end of the video. Thank you very much for watching, and I hope I helped.